Hello everyone, good morning, good afternoon and good evening wherever you're joining us from, and welcome to this online tech talk on container security in AWS Container Services. My name is Paavan Mistry and I'm a senior developer advocate with the AWS Container Services team. I've worked in AWS previously as a specialist solutions architect and as a manager within AWS Security. You have my email address and Twitter on this slide, so feel free to contact me for any questions on AWS Container Services or security in general. For the agenda of the Tech Talk, we'll first understand the fundamentals around security in the context of AWS Container Services. Next, we'll dive into the security controls available to implement container security in AWS. And then deep dive into the recently updated static container security features with an interesting demo, and look at the runtime security as well. This Tech Talk will be published in a few days on the AWS Tech Talks YouTube channel, and all the links shared within the presentation will be added to the description. We'll also timestamp the sections of the video for you to skip to the interesting bits and the demo as appropriate. So the goal of the Tech Talk is to leave you with an understanding of container security and, more importantly, the controls and tools available within AWS Container Services for you to help secure your container workloads. We'll have some time for a Q&A at the end. So before we get started and actually dive in, this is a level 300 talk. What this means is we are making some assumptions for our attendees and viewers. One, that you have a high-level understanding of Docker and containers in general, specifically what a Docker container image is, the layers, and how to work with container images. We also assume a basic understanding of working with AWS Console, Kubernetes, and AWS services like Amazon EKS, ECS, and ECR. With that out of the way, let's take a quick look at the AWS Container Services landscape. AWS offers the widest range of services for storing, managing, and running containers. This allows customers to choose the right AWS service for their workload, from small experiments to critical production applications. For container management, there is Amazon ECS and Amazon EKS. ECS eliminates the need for you to install and operate your own container orchestration software or manage and scale a cluster of virtual machines. Amazon EKS provisions and manages a confirmed upstream Kubernetes control plane and is integrated with many AWS services to provide scalability and security for your applications. For hosting containers, there is Amazon EC2 and AWS Fargate. To run containers with instance and operating system control, EC2 virtual machines give you the control of your clusters and provide a broad range of customization options. For running containers without managing servers, AWS Fargate scales and manages the infrastructure required to run your containers. This removes the need to choose server types, decide when to scale your clusters, or optimize cluster packing. To store, encrypt, and manage container images, Amazon ECR or Elastic Container Registry, which compresses and encrypts your container images, making them fast to start and available to run anywhere. With a rich set of container services, our strategy is one of giving customers choice between two great orchestration tools in our ECS and EKS, and between two launch types for each of them. There is the traditional EC2 launch type, where customers bring the instances to run their containers and get a bit more control of the type and OS of those instances, or Fargate, where we take care of that for you. To help you secure container workloads, we need to understand and build on a security strategy. A defense in-depth container security and compliance strategy involves various layers of protecting information. This starts from identifying where all your container workloads and assets are, to identifying what is important that needs to be protected or assessed. From there on, access and identity controls, infrastructure protection, data protection to protect the data at rest, in motion, in use, are some of the ways that the layered security approach is modeled. Some of the common cybersecurity frameworks, such as NIST cybersecurity framework, also call out for these use cases. Once data is protected, customers need to be aware of the threats that they might be facing with the access to data or threats they might be looking at in their environment. So to help build a threat model for containers, you may want to consider threats applicable to, let's say, misconfigured container, a host, or orchestrator, or network security controls, exposed secrets, and container escape vulnerabilities. You may also want to consider risks and countermeasures for the risks related to images or artifacts, hosts, container applications, and container runtimes. It is important and critical to monitor these events in real time and then take actions on those events. And finally, incident response includes the ability to recover and remediate from an operation or an incident. This defense-in-depth strategy can be used to model and implement security programs. Further in the talk, we'll look at some of the security controls that AWS Container Services offer that can help mitigate some of the security risks. So, cloud security at AWS is the highest priority. As an AWS customer, you benefit from a data center and network architecture that is built to meet requirements of most security-sensitive organizations. Security is a shared responsibility between AWS and you. The shared responsibility model describes this as security of the cloud and security in the cloud. So for security of the cloud, AWS is responsible for protecting the infrastructure that runs AWS services in AWS Cloud. AWS also provides you with services that you can use securely. For Amazon EKS, for example, AWS is responsible for Kubernetes control plane, which includes control plane, nodes, and etcd database. Security in the cloud, your responsibility includes the security configuration of data plane, including configuration of security groups that allow traffic to pass from the EKS control plane into customer VPC, for example, the node's operating system, if you're using EC2 nodes, and the sensitivity of the data, the application you're deploying, your company's requirements around applicable laws and regulations. From my conversations with customers, CISOs, and security leaders, one of the primary drivers when securing container workloads is compliance. This leads us to the value that compliance and certification programs deliver to AWS Container Services customers. Customers have to spend a lot of effort making sure their container environments meet internal policies and external regulations. Being compliant and audit ready can be a manual and time-consuming process. You'd need a large team plan for patching and managing software security patches. It can also be a complex and confusing operation. Third-party auditors assess the security and compliance of AWS Container Services as part of multiple AWS compliance programs, as you can see on the screen. Some of those are SOC, PCI, FedRAMP, HIPAA, and others. You can download third-party audit reports using AWS Artifact. Your compliance responsibility when using AWS Container Services is determined by the sensitivity of your data, your company's compliance objectives, and applicable laws and regulations. AWS provides resources like security and compliance quick start guides or white papers around HIPAA, for example, to help you with compliance. So having covered the fundamentals now, let's dive into the security controls for containers. But before we do that, let's understand the fundamentals of managing security risk. Okay, so in order to manage risks effectively, there are two main things. There are preventive and detective controls. Let's talk about preventive and detective controls now. Let's start with preventive controls. When we talk about preventive controls, we mean that you establish mechanisms that allow you to prevent creation of resources if they don't meet the security baseline that you define through policies and decision gates. AWS services like AWS Identity and Access Management, AWS organizations, and service control policies, for example, allow you to do this. With detective controls, as the name suggests, these controls attempt to detect actions that have occurred. They provide evidence after the fact that a loss or error has occurred, but do not prevent them from occurring. So let's look at these controls in the context of AWS Container Services and how they help you manage security risks. So one of the primary preventative controls is Identity and Access Management. You would be using this already if you're using AWS services. You can use AWS Identity and Access Management to manage and control access to your AWS services and resources through rule-based policies for authentication and authorization purposes. You can control your AWS resources by using policies that are applied to IAM users, groups, or roles. For good practices, you should create policies that are scoped to allow users to perform their prescribed jobs, follow the least privilege, need-to-know principles, create roles that are scoped to clusters and use the clusters as your primary administrative boundary. You could also limit the actions that users can use by creating pipelines that are automatically packaging and deploying applications onto Amazon ECS or EKS clusters. Make sure that you audit who has access to the Amazon ECS APIs and whether that access is still warranted. A user might change roles. After they change roles, the permissions they were previously granted to them may no longer apply. So here are some of the features you can see on the slide we have to help you implement preventive controls through IAM in EKS and ECS. We have links to deep dive sessions that I'll provide for a few of these. So we have IAM roles with ECS tasks, IAM roles for service accounts for EKS. A good example is OIDC integration with Amazon EKS as well. Now, we learned from several customers that to meet your security and compliance baselines, you want to use AWS Key Management Service or KMS to benefit from AWS managed or KMS keys that you create or own. AWS Container Services provide this integration, and we have several features that help you secure your containers and implement data security controls using AWS KMS. So whether it is Kubernetes secrets in EKS or ECR's image encryption, customers have control over keys for these encryption using KMS. Some customers prefer the audit, access control, and monitoring features using these keys with control over key material origin. With the KMS key integration, customers now have the ability to select key material origin for their keys from KMS, an external provider, or even customer key store, which is using AWS Cloud HSM. To assess security configuration against industry standard, we also announced CIS EKS benchmark to assess EKS node security configuration. So for most of the topics you see on this slide, I have done a separate tech talk or a deep dive session for each, so I'll provide links to those, or feel free to ping me directly if you cannot find them. A good example of detective control is a new feature that we recently announced for Amazon EKS. Amazon Guard Duty is a threat detection service that continuously monitors your AWS accounts and workloads for malicious activity and delivers detailed security findings for visibility and remediation. So we recently announced Kubernetes protection in Amazon Guard Duty to detect suspicious activities and potential compromises of your Kubernetes clusters within Amazon EKS. Kubernetes protection is an optional enhancement which enables Guard Duty to consume the data sources from Kubernetes, like your Kubernetes audit logs. And when it's enabled, GuardDuty uses these audit logs to detect threats against Kubernetes API and monitor them for malicious and suspicious activity. Of course, CloudTrail is a great way to ascribe AWS API calls to specific IAM principles. And to monitor, store, and access log files from the containers in your, let's say, Amazon ECS tasks, you should specify AWS logs log driver and in your task definitions. And also on EKS, the audit logs are sent to Amazon CloudWatch logs. So you can use these detective mechanisms to add those controls to your environment. For ECS and EKS, I have contributed to publishing security guides for our best practices with my colleagues that you can refer to and digest some of the very interesting container topics we are unable to cover here, like network security or incident response and forensics, since there are a few more interesting things that I'd like to cover next. You can use these two security best practices guide for informing yourself and making decisions around security configuration, controls available in the various aspects of the two orchestrators, Amazon EKS and Amazon ECS. So let's look at static container security, and I'm really excited about this new feature which we introduced at reInvent last year. Amazon Inspector was launched in 2015 as a vulnerability assessment service for EC2 instances primarily, and we had a really good response from customers regarding Amazon Inspector. But a few things have changed since 2015, and what I heard in my conversations with customers is reflecting those findings that the Inspector team had to report. First, a lot of solutions the customers were using weren't designed for containers. Containers are very elastic, easy to use for workloads to spin up and spin down. And a lot of time customers were saying that, look, I don't know if I'm capturing my entire environment. These containers spin up very quickly and we have a short amount of time to respond to that. And some of them might be vulnerable. So we'd like you to solve that for us. Second, they were spending a lot of time managing these solutions. So vulnerability management is important and it generates a lot of findings, and customers didn't want to manage another security agent and prioritize the results and spend their efforts there. So they want to reduce their effort cycle in that aspect. Third, customers spend a lot of time managing these solutions. They understand vulnerability management is important, but the cloud is also dynamic, and customers weren't just sure that they were covering the full environment. So application teams were launching things every day, and there were gaps that they weren't aware of. So they wanted us to solve that as well, in terms of discovering all the resources and building dashboards and making things visible. And thirdly, they wanted to set boundaries between operations and development teams on how to view and remediate the vulnerabilities. So the core guiding principles of the new Amazon Inspector is that security teams shouldn't be focused on upfront activities for vulnerability management, like deploying a solution or managing security tools, and even completing kind of initial analysis and triaging to what to remediate first. Instead, security teams should focus on managing remediation of these findings. And in order to help them do this, Amazon Inspector now has 3 core features for container static scanning. First is multiple account support. Second, consolidated dashboard view. And the third is a contextualized score for remediation and prioritization. In addition to that, enhanced scanning, as we call it within Amazon Inspector, it has continuous scanning feature, which allows you to continually scan the images. And then additionally, on top of scanning operating system packages, it also scans programming language packages, which is great. So, and there is always a choice between basic and enhanced scanning mode. So if you want to go ahead with the free basic mode, which was the case in ECR previously. That is for free, and customers can continue to use that. But with the enhanced scanning mode offered by Inspector, you have these features that allow you to manage these vulnerabilities at scale across AWS accounts. So let's take a quick look at how it works. In terms of you having a client which pushes the image out to Amazon ECR registry, you would configure your registry for enhanced scanning. And once it's configured to do that, you'd have Inspector detect that there is an image pushed with that particular filter or tag, and it will automatically scan the image's OS and programming language packages. After doing so, Inspector prioritizes these findings and sends it to AWS Security Hub, which is another service which allows you to gather results from various sources. In this case, we have Inspector sending out findings and events to Security Hub. And the key benefit here is it's continuous scanning across multiple AWS accounts. Inspector has partnered with Snyk to receive additional vulnerability intelligence. So you can have that rich set of finding informations, rich definitions around what Snyk has to provide for the container scanning. So this should help set some context for this particular feature, which I'm really excited about. And now let's look at the demo, which shows these features in action around a recent vulnerability, which was the log4j vulnerability around early December, which impacted a lot of customers. Okay, so here we are in the console, ECS console. We click on private registry, and we see some new options here around scanning. The two different scan types are basic scanning and enhanced scanning, as we learned about earlier. And basic scanning is provided by default for your private registry. So looking at our CLI, I'm going to run. So right now, we don't have any Docker images on our local machine or processes running. So I'm going to run this instruction, which allows enhanced scanning or enables enhanced scanning for this particular registry. It's a registry level feature rather than a repository level feature. And now that this has been enabled, what it will do is for any repository or image pushed with a prod tag on it or a prod name filter, it will run an enhanced scan, and without that prod filter would not run the enhanced scan. And hence you can differentiate between those. Now we'll create a couple of repositories, one with the prod name and without. So the second repository I'll create is without the prod name, so that it doesn't trigger scanning for that particular repository. If you go back and look at the registry, we'll find those two repositories created. So now I just want to take you to take a look at the credential store, ECR login, and the configuration I have in my local Docker configuration. It refers to the credential helper project that we have open sourced, and you can go ahead and install in your local machine so that you don't have to authenticate with ECR every time you do a push. So in this case, we'll pull from a public repository. We know we want to pull a vulnerable image. In this case, we know that Neo4j has that particular vulnerability in this particular version or tag. So we'll retag it and push it to our prod repository so that we can see the triggers and the scan results. We'll also do the same in the next few steps around the test repository. So here we're just pushing it to our repository that we created, and that should trigger the enhanced scanning using inspector. And for this particular one, the scan repo test, it is being pushed out to our private repository within ECR, and because it has test and not prod filter, it will not trigger the scan from inspector, and it won't continually scan. So going back to our console, we find that you have vulnerabilities finding, but more importantly, there is a scan frequency which is represented in, which is very useful, where you can go ahead and look at the scan frequencies. In this case, scanning is off because it's outside of the tagging specification or the filters that we specified in our enhanced scanning configuration. And we can directly go ahead and look at the findings from the ECR console, which is quite useful. So as you can see, this particular image has many findings which need to be addressed. In particular, the log4j finding, the CV 2021-34, 429 and 44-228. So those were the two critical vulnerabilities found in December, which when we click, you end up going into inspector, and it provides you more information around this vulnerability in Apache log4j. So you have an option to export these findings in JSON or CSV formats, and you can create various export locations as well, and you have a good view, and you can slice that view by vulnerability, by instance, or by container image. That's what we are interested in, and we can look at what kind of findings do we have. So in this case, we have the actual image, and this is an interesting view where you can look at it by a layer. So you can, and this is very useful, where you can not just look at the image and the overall findings, but also which layer within that image or artifact has that particular vulnerability, so that it's not replicated into other images, artifacts using that particular layer. So that's a very interesting view, and that's something nice that Inspector have done. So when we click on all findings, we get all of them, and we can create suppression rules. If you think there is a particular false positive that keeps on appearing, you can create a suppression rule. And here's a nice view around what coverage you have for the environment, what repository has most critical findings. Imagine having tens and hundreds of AWS accounts. It's really hard to control, but if you have this policy set within organizations, and you have this control as a policy, then you can go ahead and look at those findings. So in the dashboard, you have the environment coverage, which is 50% of the repositories are being scanned using enhanced scanning and is enabled as we expected. You can also go to Amazon ECR. So one, for the prod repo, we have it enabled as the filter, and for test, it's not enabled. So you can go to Amazon ECR and then manage your repositories from there as well. And let's go into Security Hub so that you can see how Inspector pushes these results out to Security Hub as well, and you can export or import along with your SIEM solutions or other solutions that you're using within your enterprise. You can gather and have a single pane of view around managing these vulnerabilities, which was the headache, or which was the request that customers asked for, in terms of they weren't able to manage the volume of repository or the vulnerabilities that they were seeing, and they wanted a single place to manage these vulnerabilities and prioritize them. And that's the core job of a security operations team, around keeping track of all these vulnerabilities and managing them or closing them based on their score and priorities. And that's this is a blog that we did. I did around the feature, so they can feel free to refer to that. And hopefully this gave you a view into how enhanced scanning helps our customers to secure against vulnerabilities or static container security. So as mentioned previously, in addition to enhanced scanning, ECR does maintain the basic scanning functionality, which is free scanning on image push. And in this case, when you push the image, every time there is a push, ECR scans and looks at the image OS and returns the results to ECR. And this repeats every time a new image is pushed. And it uses Claire as a scanning engine behind the scenes, which we have documented in ECR documentation. And one of the roadmap highlights is to upgrade that version of Claire to version 4. And also that moves us nicely into one of the next or forthcoming features, which we are pretty excited about discussing, is container image signing, which is the last item in this roadmap. But before we go into container signing, I'd like to point you to this particular presentation, which I did last year, around using or building security in a real world kind of scenario, where you build a container application which leverages some of the controls that we looked at previously around preventative and detective controls, and how they can be folded in to a real world example using ECS, Fargate, GitHub Actions, and the functionality of scanning within ECR in a CI/CD pipeline. So how can you automate this and make sure security is embedded into your pipelines? And container scanning is interesting for engineers who are interested in looking at false positives and negatives coming out of these scan engines. There are various open source alternatives around the scan engine scenarios, where you have open source products like Trivy or Anchor, along with Quay and Claire and Sneak, which you may want to look at and try out using GitHub Actions or any of the automated services, which allow you to look at what kind of results you're getting and what meets your security risk appetite in terms of managing those vulnerabilities and addressing them. So let's look at container image signing, which has been one of the requests in this issue, as you can see, which is tracked in our containers roadmap. Customers have been asking for image signing for establishing trust. And one thing customers would like to do is understand how can they trust the personas that are pulling those images or pushing them to ECR, and making sure that in a really large organization, you can trust the content. So this is something that we are currently working on right now, where we are aligning with an open standard to sign and verify. The open standard is Notary v2 spec, and we want to keep signatures associated with the images during push, storage, and pull, which is the actual spec, and address signature verification within Amazon ECS and Amazon EKS. So keep an eye out into these open source projects and contributions that we're making. So let's jump into runtime container security. And to understand runtime security, we need to understand Linux capabilities as such, amongst other things. Linux capabilities are used to allow binaries executed by non-root users to perform privileged operations without providing them all root permissions. So there are currently 40 capabilities supported by Linux kernel. Docker supports the Linux capabilities as part of Docker run command with cap add or cap drop flags. And by default, a container is started with several capabilities that are allowed by default and can be dropped. So other permissions can be added manually. So as you can see in this example on the screen, we have a Debian container which is starting without any capabilities with the standard Docker capabilities, and then we use cap add to add sysptrace, which is a specific capability around enabling ptrace syscall. So the default configuration of Linux capabilities that are added or removed from your container are provided by Docker if you're using Docker. And then the tasks that are launched on AWS Fargate only support adding the sysptrace kernel capabilities. So if you want to specifically add a capability to Fargate, the only supported one right now is sysptrace, which is a capability for kernel syscall tracing. We have done a great deep dive on our containers from the Couch Show, and I produced a GitHub repository around looking into how you can use this with our partner solution from Sysdig, Falco, which allows you to go deep into the kernel tracing and making sure you're having the visibility of the actions once you are pushing a task to Fargate. And it's a really interesting conversation which I have with my colleagues and demo that solution to you. So do have a look. And for EKS runtime security, we recommend using admission controller based solutions like OPA, Open Policy Agent, Kyverno, or Gatekeeper to implement runtime security measures that include things like deny privilege escalation or deny running as root, deny mounting host path, and dropping Linux capabilities. These will help you mitigate the risk of an attacker escaping the confines of a pod or a container and getting access to the host. If you require additional controls, you can add AppArmor or SecCom profiles, and there are, in addition to Falco, which I previously mentioned, there are solutions from our AWS partners like Aqua Security, Twistlock, and StackRox. So all of these providers provide features and services for runtime security. So here are some additional resources which are aligned with the controls and the security mechanisms which we discussed previously that you can refer to. I'll make sure that these are within the description of the YouTube video, which is probably will be published within a couple of days, if not later. And so let's do a quick recap around what we covered today. We started with the understanding of defense in-depth security and compliance strategy to help manage security risks in AWS container services. We also looked at preventive and detective controls available to improve container security posture that you can use today. And finally, we demonstrated how continuous scanning with Amazon Inspector and ECR can help with vulnerability management along with runtime security. So thank you again for attending this session, and we can open up to Q&A, and I look forward to your feedback. Thank you very much.